Welcome to our November Community Advisory Group meeting. My name is Daniel Isofano, and I will be moderating tonight's session. We'll do a quick round of self-introductions. I will pass the microphone around. Phil?
I'm Phil Price. I work at the lab. I'm also on the board of the Golden Gate Audubon Society, a local birds and nature organization.
I'm Lynn Aleknowitz. I am with the Nyingma Institute, and I live at the Nyingma Institute.
I'm Chris Adams. I'm a community member, and I live about 2.5 blocks north of Lynn.
Paul Lick, director of the UC Botanical Garden. Phil, did you see this red start that's in town?
Elizabeth Stage, Lawrence Hall of Science, and I live in Claremont Canyon.
Carol Schemmerling, Strawberry Creek Watershed Council, and I live in the North Berkeley Hills.
Unfortunately.
I'm Rich Sextro. I'm a lab retiree and a community member.
Allegra Kim, California Office of Environmental Health Hazard Assessment.
Paul Olivasatos, I'm the lab director.
Sam Chapman, I'm the manager of State and Community Relations at the lab, and we have Polly, who just joined us.
Polly Armstrong, CEO of the Berkeley Chamber of Commerce.
And longtime Berkeley resident and former city council member.
Excellent. Well, thank you for attending what is our last meeting of the year. And while we're on the subject of meeting dates, there is a handout referring to the meeting dates that are tentatively scheduled or proposed for 2014. Please check it out. These are not completely firm yet, so if there are issues with any of these meeting dates, we might still be able to make adjustments. So let us know as soon as possible. We'd like to get ahead of the curve so we can plan our meeting content and presentations accordingly. For example, tonight we do have Paul Alivisatos, our lab director, making a presentation on the state of the lab. We do have the synthetic biology presentation and discussion now scheduled for January 13th. So we needed the extra time to get all the speakers lined up. We know that's an important topic that was suggested by CAG members as a meeting topic, and we want to follow through on that. And so as we normally do, once we get into the first of the year and even beforehand, if there are ideas or suggestions for meeting topics, we can start to acquire those. So send in your emails or ideas, and we'll start to put together a really solid program for next year. And we do want to build that off of CAG member suggestions. We can bring in ideas, but it should be discussed here with all of you going on to the January meeting. So we have synthetic biology for January 13th at this point. So tonight, our usual update items, first of all, on Richmond Bay campus, and then also on current and possible future design and construction projects at the lab. And to get us into that material, Sam, please.
Thank you, Daniel. It's good to be back.
Switch up. Oh, sorry. It's on the body. Yeah.
Got it, I think.
Yeah.
Okay. I missed the last CAG meeting, which was the first CAG meeting I missed, so it's good to be back. And the update today for the Richmond Bay campus is very timely because we just released the draft environmental impact report and the revised long-range development plan on Friday. We put all CAG members on the distribution list, so you should have received an email with links to those documents. And if for some reason someone didn't, please let me know, because we want to make sure you receive all of that kind of information as soon as it's available.
It's really nice to get that as soon as it came out.
Thank you. Thanks, Polly. So the general timeline now is we have a 60-day public comment period, which began November 15th. We have a public hearing scheduled in the city of Richmond on December 11th, and the comment period will end on January 13th. So the documents are available for oral comment, for written comment. We invite you and anyone else you know to examine them and provide us your comments, and encourage anyone who might be interested to take a look at the documents. At the end of this process, at the end of the 60 days, we will then proceed with our colleagues at UC Berkeley to work on the final environmental impact report and to finalize the long-range development plan. And we're still on track, we hope, if we stay with the schedule, to take the documents to the regents in May, and that the regents would certify the final documents, and that would be the end of that part of the process. So that's where we are with Richmond Bay campus. I think Glenn Kubiak at the last meeting provided you with an update on what's happening with potential development out there, and I think he mentioned that UC Berkeley hired a development manager, and that person is on board and looking at possibilities for how to develop that site once we complete the planning and environmental review process. So I think that completes that part of the report. Are there any questions?
Any questions, comments on the Richmond campus?
Okay. If not, I would like to say a word about our next speaker. Jennifer Ridgway, who you've come to know over the last year or so, who was the head of facilities, has left the lab and is looking for opportunities closer to home. She's been commuting from San Jose for all of this time and is excited to find something that's closer to where she lives. And filling in for her tonight, and perhaps for some time in the future, is Stan Tucholsky. And Stan Tucholsky is the head of design and construction in facilities. So he oversees all projects that the lab is involved with, and is very capable, and has now been with the lab for, 6 months or so? 9 months, okay. So he comes to us from another laboratory, so he's familiar with laboratory culture in general, and he's a very capable guy, and I've enjoyed working with him, so I'm sure you will enjoy hearing from him and having a dialogue with him about projects. So Stan, you're up.
Well, it's nice to hear that somebody thinks you're capable. If I was incapable, I don't know what you would have said. So this evening, we're going to do a brief presentation of about 20 minutes just to cover the ongoing construction that we have on site. It's been an exciting 2 months up at Berkeley Lab with all 4 of our major construction projects going through some really big changes. So just to orient everybody to site, again, the large construction projects that we have ongoing, or if you follow up the hill from the bottom of the hill. Does this thing have a laser? There we go. We've got the CRT construction project. We've got the Flex Lab construction project, CERC, and GPL. And all 4 of these, again, have gone through dramatic changes over the last 2 months. So maybe starting with the most obvious of the changes to our site has been the work at the CRT project. So I'm sure folks have seen the visible bright yellow Biggie crane that we have on site. It's been up here for about 6 weeks, and we've used the crane. So I have some pictures of the crane. We've used the crane to start building the steel frame that forms the basic steel structure for the CRT. So here's the front entry gate. Here's the crane, and the crane will be on site for about another 2 or 3 weeks. It'll be leaving us at come the holiday season. The first story is all concrete construction, and that houses all the mechanical equipment to cool the computers. So the large air handling units sit underneath in this floor here. All the heat that's ejected to keep the computers cool is ejected from the cooling towers, and those cooling towers were lifted I would say about 4 or 5 weeks ago during a football game, I had an opportunity to see those go in one at a time. But there are 4 large cooling towers over there. So this I would call a concrete podium. Again, the mechanical equipment sits here, and the large openings that you see there are for the louvers for the air intake for the air handlers. So the crane came, and we began building the steel structure, which sits again on top of this concrete podium. So here's the base first floor where the equipment sits. The computers sit on top of that floor. And then there are 2 additional office floors that you'll see go on top of that. And our planned topping out ceremony will be in about 2 weeks, and topping out is when we put the last piece of steel on top of the building. So we're about 2 weeks from topping out, and for folks that have a view of the CRT, the level of steel that you see up today, that's the roof level, so that's as high as the building will go. And one more view here for seismic stability in an earthquake. We're using what are called unbonded braces, and they're a specialty form of construction where there's a steel pipe which has concrete which goes around a thin steel ribbon. And that's designed to do well with the near fault, of course with the earthquake fault nearby, but they're also replaceable. So the ends of the braces are bolted into the structure, so if we did see an earthquake and there was damage, they could be replaced. That's kind of one of the interesting features. So moving on to the general purpose laboratory, that's the last structure of our seismic phase 2 project, and the completion for that is moving forward quickly. We've already begun the commissioning process. So I think when Jennifer was here last time, 2 months ago, we would have just begun the process of energizing the building. So now it's been interesting to see the building come to life. We've turned on just about all the mechanical equipment, including the chillers and air handlers for the laboratories. And now all the lights are functional in the facility. So here's a look inside. We have 3 stories. Each floor plate is split kind of 50-50 with laboratory, general laboratory space on one side and office space on the other side. And this is a general configuration of the lab space. We have utilities that drop down from the ceiling, and then we have pretty standard lab benches which open up to windows along the outside. This is what our meeting rooms look like, and there's been a lot of discussion on the construction team about who's going to try to come get dibs on having meetings inside and lunch inside some of these nice spaces, because there are some nice views out of the window. The construction of these spaces is a ground concrete finish. It's a very durable floor, but very nice for a meeting room. This is a standard kitchenette space. This is what the office space looks like inside the GPL now. So the carpet's in, the space has been painted. These little flags that you see down there in there, so we can begin the testing and balancing of the air handling equipment. And finally, this is what one of the meeting rooms looks like. So the lights in this space are dimmable so that we can use video projection. So the Solar Energy Research Center sits immediately adjacent the GPL building, and it's a little bit earlier in construction. It has a planned finish date of about a year from now. So this is a view from on top of the hill, taking a look down at the CERC building. There's a large concrete extended basement, and this basement is there so that we can do light sensitive and vibration sensitive research in the facility. So the footprint, the square footage is about 1/3 or 40% in this basement, and then again 3 floors with lab space on top and offices in between. So where we're at with this project right now is we're just starting to get the metal panel cladding all the way around the building. So this little strip of color here is the actual finish of what the building will look like. It's been quite interesting taking a look at the building as I go home in the evening, because these panels actually pick up some of the color from the hillside and from the sky. So the building will be unique in that respect. I think it will change color a little bit in the evening. So we're getting very close to waterproofing the building. We're putting down waterproofing and roofing on these spaces. One more view. And then on this side, this is the west facade of the building. We actually have a living roof that extends out. So we're completing the waterproofing there, and we're going to begin putting down the different membranes across on top of the existing roof, or the living roof. This is some glass facade that faces west. And then inside of the Cirque building, we've got all the walls that are in place. We've got quite a bit of ductwork in place. All the mechanical equipment and significant amount of the laboratory equipment has been received and installed. Here we can see the electrical equipment in the basement. So again, we're about a year away from completion on that project. So Flex Lab. Flex Lab is probably the most interesting 15-point-something million that facilities has worked on recently. The whole project is designed to be a research facility for different building technologies. So again, we've seen quite a bit of growth in the project over the last 2 months. There are 4 what we refer to as fixed bay test beds, and that's 2 lower ones and 2 higher ones. And then in the foreground here, this test bed actually rotates so that it can capture different sun exposures, either in a fixed manner or to track the sun for different research projects. So if you can kind of catch that arc right there, that's the extent of the rotating footprint. And this entire building is sitting on a steel rail system. So the vendor has come out, the controls are around the corner here, and when a button's pushed on this side, the building rotates, I think it's 270 degrees. Very slowly, but still, so it can track the sun. The construction of the Flex Lab has been very specialized, wood and insulation, so that each of the test bays is isolated from the adjacent test bay so that the experiments are independent. And they've also been set up so that we can simulate a whole wide range of different type of building conditions. So when I chat with the folks from EETD, which is the organization that's standing up the program, they like to liken this to a Walmart, a Target, and then you name the other 2. So it can be just about any type of building facility that we have, in the country. And then they're doing all sorts of energy retrofits and systems, and they're looking at springtime perhaps for their first customer there. And that'll be industrial partnerships that come to do research at the Flex Lab. So this is a view looking to the west. These are the fixed bays. And these steel girders that you see, steel columns that you see on the front, they're there so that they can attach all sorts of different window systems depending on what type of research they're doing. And a view looking to the south. Sure.
So this is not necessarily for research that people at the lab are doing, but it's like rental space for people around the country who are doing this kind of research to come and try it out?
So this is for the folks who are doing research into the energy efficiency of buildings. And each unit, there's 2 side by side in each one of those. So one can be kind of a control and the other a test. And you can change out the windows, the lighting, the air handling. And so and to do combinations of those. Because today, for example, the people that would sell the windows in a building don't really coordinate those as well as they could with the lighting and how the air handling and all of those things work together. So, yeah, there are projects that they're going to do that are just their own research projects, and then there are lots of vendors of various technologies that would like to understand how their different things would work together when they're all put into one building.
Are there other similar places in the country, or is this a one-of-a-kind gift
There's
that
another
draw a lot of people?
There's another facility this is being built with stimulus funds, money that comes from those funds, and and another project like this, similar in spirit, is being done at the Oak Ridge Lab in Tennessee, which will be for residential. So, there'll be sort of two cousin facilities that way in different parts of the country. Yeah.
Okay, great, thank you.
So in keeping with the research, there are several pieces of mechanical equipment that are mounted on the outside of the building, and part of the project is actually to produce the control programming so that non-specific, non-vendor specific controls can be used for the different pieces of equipment. And then one other interesting thing about the project is that inside on the floor, they have the ability to do radiant cooling and heating with tubes that they pump water through in the floor. So they have conventional forced air systems up in the roof, and then they also have the radiant systems in the floor, and most of that is fed from this equipment that's being installed in the back. And then one quick note on the Wilson slide. I know Jennifer has reported on our progress, but about 2 months ago we finished the effort and the slide is completely stabilized, and we're looking forward to getting a little bit of rain because it's been hydroseeded. So you can see the straw wattles and the straw rolls, and this is all hydroseed, and to the extent that we could, we regraded the hillside back to its natural state. Thank you very much.
Okay, very good. Thank you, Stan. Any follow-up questions or comments for any of those items on the construction projects update? Good. Well, let's move on to our feature presentation. Once again, we're fortunate to have our lab director, Paul Alivisados, tonight to provide an overview and update on the state of the lab. It's become an annual feature of our CAG meetings, and we've gotten good feedback on these in the past, and so we're looking forward to Paul's remarks here this evening, and also to use this as a jumping off point as we think about future meeting topics in the year ahead. So we look forward to Paul's presentation, and any ensuing discussion or questions or comments are welcome. And we've set aside time for us to spend with Paul in this sort of conversation and dialogue about the goings-on at the lab. So we'll get our computer set up and we'll be ready to go here. Yes, Lynn?
A question just based on what the agenda says. It was an update on current and possible future design and construction projects, and it looked like we mostly looked at the ones that are in progress, and I just wonder if there are any future construction projects under consideration.
Beyond these featured ones. Okay, Stan, do you want to comment on any of those, or Sam or Paul? Future, beyond the ones that are currently on the books or in construction.
For quite a while, we talked about seismic phase 3, and the CAG was informed that there was likely to be a seismic phase 3, but with the funding environment in Washington, we don't have a seismic phase 3 lined up right now, and so we will be informing the CAG as something develops that is a real project that we expect that we will have funding for. But part of Paul's presentation, I think, is to look ahead at what the future of the lab is. So why don't we hear
I'll try
him
to address it. There's nothing
talk
in the
about where we
pipeline.
are?
You know, the pipeline is, yeah. So, I'll make this brief presentation, and then I really would like to just engage with you in a discussion around what it is that's going on at the laboratory and more broadly, so you can get a feeling for the circumstances that we're working with. And I guess the way I would preface it is by saying that the last time that I spoke with you would have been in January, and the budget environment between then and now has become a great deal less favorable for us in pretty much every dimension. And the effects of that are palpable and are requiring that we reevaluate many aspects of our strategy, simply because the prospects for the next period of time really don't look as favorable as they did in January, which already were kind of not so terrific, but it's gotten quite a bit worse. So, I'll just go through what I see happening there, and I think I'll start by giving you a little bit of a story here. This is Odysseus, who, of course, leaves the Battle of Troy and seeks to get back to his home of Ithaca. And as he engages in this journey, he has to contend with the jealous god Poseidon, who deals with the rivers and the oceans. And he's protected, of course, by Athena, the goddess of wisdom and war. And all of the other gods kind of get into the business periodically. And he ends up having this incredible journey through many perils until he finally does find his way back. So this is a kind of a map of antiquity. Let's now look at the map of austerity, which is what we are facing, okay? And so the Trojan War is, of course, the annual budget process for us, which is quite messy. And we can look at these various gods and assign names to them. So, for example, the goddess of wisdom will, of course, be the Department of Energy. And Poseidon, who is always upending our plans, will, of course, be the Office of Management and Budget. And the, gods up above are the Congress. And our intrepid hero is, of course, trying to make the way back to Ithaca. And there's all kinds of places like the Lotus Eaters where people, believe certain things. Those we could think of as kind of the think tanks that also get into the game here. But as we try to navigate all of this, there are all these perils that we go through. And for a number of years, we've dealt with the fact that there's been no real budget, actually, most years. There's only been what's called a continuing resolution, which just means the budget looks just like what the budget looked like before, which actually right now we would trade for that. But for a number of years, that was not so terrific for us, because when you have a continuing resolution, it's hard to start new things. And we sort of thought that we had found kind of that was kind of, as bad as it gets. But recently we've been through these things like the debt ceiling limit and the shutdown that were really kind of traumatic events for everybody that was, engaged in scientific research, as well as for people in all kinds of aspects of life that our public sphere funds. And that involve important functions that the government executes. So we're trying to stay, focused on what our goals are, and to keep science going and find some way to come back to, where we think the Berkeley Lab should be. But it's quite a journey, and it's really quite hard right now. So, you have to realize that those are some of the backdrops, and then I'll go through some of the things that are going on. So, things that we can say. It's certainly true that the team science approach and the very strong relationship with the Berkeley campus is a hallmark of the laboratory and will still be. There's a lot of scientific discovery going on every day at the laboratory. And compared to, say, 10 years ago, our work in energy and environment has really grown enormously and is very important. and is really going to be a key part of our future. Meanwhile, there's lots of other wonderful things going on at the laboratory that I'll describe some of at the end in terms of understanding the universe that we live in. I'm just almost 5 years into being laboratory director, so I will show you what some of the things were that we were working on over the past 5 years, and then show you how we're revising our strategy in many cases. So last time that I talked to you, this would have been the set of initiatives that the laboratory was working away on. And so we'll start with Carbon Cycle 2, which is, of course, the effort that we've been working on to guide the laboratory in its energy and environment agenda, and also to try to provide a scientific basis for a future carbon cycle that's balanced and not out of balance. And we've had a number of successes there in terms of establishing new programs, and those programs are starting to do a lot of good things. And so we're now going to be thinking further about not just building science programs, but we're going to be thinking a little bit about how those science programs could do more in the spirit, for example, of the Flex Lab that you just saw, where there's activity at the laboratory that ties between the science and helping have a real-world impact. In computing and networking, that's an area where the lab has unusual strength compared to most laboratories, and so it's going to be the basis of a forward-looking initiative. In fact, one thing I could say is that as I'll tell you about the forward-looking initiatives, all the ones that we're planning for the next period of time, and they're under discussion right now, they're changing, but they're being developed, all of them are ones where we're not going to try to do something that we're not, they're all going to be based on things that we're already quite good at because we live in an environment where, the competitive basis for being successful in that is just a whole lot better. It's hard to start something completely new. When I came into this position, I set as a lab-wide goal to try to make our community relations be stronger. And I think it's fair to say that we've made progress in that space. There's still a lot more to do, but we will have another initiative here that corresponds to a kind of, I think we've had a kind of cultural transformation inside the lab where people recognize throughout the lab that this is a vital part of what we should be, of our values. So we'll be having another kind of cultural transformation initiative, as you'll see. And in the safety space also, we've had a very substantial change in the safety culture at the lab in the past few years. So we're going to try to build on that. Now, when I spoke in January, I did give you a presentation that dealt with the question of what would be the future of so-called light sources, and I talked a little bit about free electron lasers and things like that. Very new ways of making light. And our lab played a very key role in thinking through those kinds of issues. We had been thinking that potentially there might be a facility at the laboratory related to this, but ultimately that's not going to be the case. And there's going to be a new free electron laser built at Stanford, but not at Berkeley. And we are going to be looking at taking the existing light source that we have and upgrading it. So you'll see some of that. And we've talked a lot with you about the Richmond Bay campus, and our plans had been to place our biosciences at the Richmond Bay campus. But the budget environment is not going to be friendly to us being able to do that. There's just not going to be in the next period of time the resource that would be required to make that happen. So we're in a very close dialogue with UC Berkeley, and we're developing what I think is a very good plan for a different set of activities that we will be doing at Richmond. So a lot of changes. So these are the scientific and other initiatives that are currently under development at the lab in response to the circumstances that we find us in, and trying to take advantage of what we think are things that we're very good at, and also put together initiatives that will be impactful for society. So there are 3 science initiatives here, one kind of more technology one that relates to a cultural transformation that's very important for the laboratory to undergo, and one that involves trying to improve the operations of the laboratory. And so these initiatives, as you'll see them, are one in the biological space, one in computing, and one based on the light source that we run already and trying to improve upon it. Now, let me say with respect to this area, the biology, that our laboratory is amongst the DOE laboratories probably the leading laboratory in the applications of biology to issues of energy and environment. Okay, so there's a reason for us to build an initiative here. And likewise in computing, we have some exceptional strength there in certain aspects of computing that we're going to try to take advantage of. And of course, the light source we run already. So let me start and go in through to show you these initiatives. The first one we will call Microbes to Biomes. So I think there's very clear, a more clear understanding emerging almost every day that microbes play a great role in determining both our health and our environment, more so than people had appreciated. If you're a devoted NPR listener, then in the last week or so you've been hearing the human microbiome, which describes how it is that the microbes that occupy the human gut end up, and the rest of the body actually, all over the place, how they end up playing a much more critical role in determining who a given person is and what they are like and how they respond to different circumstances than people had realized previously. And that's because there are about 100 trillion microbes in a human body, and the microbes represent a couple of 2-3% of the mass of your body. So, they're a significant part of who we are. And they control chemically a lot of what goes on, and they do all kinds of things. Well, the same thing is actually true for the ecosystems that we live in. The microbes are present in vast numbers, and actually they determine very much what a given ecosystem looks like. And so what we would like to do in the future, we've reached a point now where we can understand individual microbes at a very great level of molecular detail. And we are beginning to understand how it is that many different microbes talk to each other. To give you an example, if you take a piece of soil and you look inside of it, there will be, in a very tiny piece that you will look at, as many microbes as there are stars. And when you look at those microbes, you'll find that there are different populations. Some might be present in very, very tiny numbers. But if there's a change in the environment, suddenly they become a much larger fraction of the population. We're beginning to understand how that works. And it's a very important thing for understanding the environment. And it's very important also, just like we depend on the microbes that are in our gut, so the plants depend critically on the microbes that, for example, might reside all around the roots of the plant and which are responsible, for example, for helping the plant to fix nitrogen. If we could learn how to do that more effectively, that would make an enormous difference and reduce human impacts in agriculture and all kinds of things like that. So we're planning an initiative here that will go all the way from molecular level understanding in genomics and understanding at very tiny molecular levels what happens in microbes, all the way up towards complete ecosystems. And so that's our Microbes to Biomes initiative at the laboratory. And at the heart of this is the question of how will ecosystems respond to climate change. We have some folks now at the lab who go to the Arctic and to the Amazon, and they collect samples all the time. And in places where the climate is changing, they're bringing home the microbial species and trying to see how those are changing and to understand how that is going to figure into the future of what those ecosystems will look like. And so that's an aspect of the kind of field work. So it goes all the way from lab work to intensive field work. So let me come now to the computing aspect of things. So we're talking about, if you read the newspaper, you will of course be hearing all the time about big data. And mostly it's not a very comforting topic for people. But in the scientific world, there's also a data explosion that is going on, and that's illustrated here. This shows on a relative scale the growth in computing power compared to the growth in the amount of data that is generated by experiments. And what you can see is that the amount of data that's able to be collected and observed is growing at an even faster rate than the rates at which our computers are growing. And so we would like to create a new initiative in this area that brings together several features. One thing that you may not know about the lab is we run for the Department of Energy the highest speed data network in the world. It connects all of the major sites in the United States that deal with large amounts of scientific data. And it also connects to sites in Europe, Asia, and South America. So we run that large network. So we have the ability to help facilitate the transport of these huge amounts of data. We have a large supercomputer, one of the best applied mathematics groups, and of course a number of user facilities at the lab. So for all these reasons, we have been trying to place the Berkeley Lab in kind of a central position with respect to this question of scientific data explosion in the deal. Yes, of course. Yeah. So, to give you an example of the kinds of things that are of interest to us that might be related to this area of the scientific data, here you can see the climate models and how the climate models have been getting better. For example, in 2006, when we made a climate model, we had to try to study how the temperatures vary in grids that are having a side of about 200 kilometers. And in 2012, that's at about 25 kilometers. And in 2022, we're hopeful that the grid size will be about 1 kilometer. And you can see that in 2006, it wouldn't really be possible to make a very meaningful model of what goes on in Northern California. But as we get closer to the end of this decade, it will be possible to actually make a much more careful projection of what, climate things might be going on. Yes?
Sorry, I think actually if we go back one more.
Sure.
I think Paul asked, is that an increase in percent or a fact? I think that must be a factor, right? Because power.
Yeah, it's a factor. Yeah, it's a factor. Thank you.
They heard from Michael Renner at the last CAG meeting.
Oh, so you saw some of these things before. Okay, I didn't know you had seen that. So you saw this, for example, already or not? This shows, for example, an estimation in different scenarios, lower and higher emissions, for what the current models that we're running show will happen to the snowpack in California. And you can see that towards the end of the century, even a low emission model shows most of the snowpack being gone. So big changes, and tying that back to what I mentioned to you in the biology efforts, we're trying to also understand how the ecosystems respond to these changes. Now, let me give you a feeling for this data and what we're talking about, what it means to us. For example, at the light source, the ALS that I'll be showing you in a minute, people collect data on different experiments. And do you have a terabyte disk? Many of you probably have a disk that you store things on that might be, instead of being hundreds of gigabytes now, it'll be about 1 terabyte. So they fill about 10 of those 10 terabytes a day. Right now, today, that's how much data is collected on that machine. But actually, by the end of the decade, that number might have increased by a factor of 1,000. And likewise, we can compute the properties of materials. And so today on the computer, people are, Christine Person and her colleagues are computing the properties of solids before they've ever been made. And there are thousands of users coming and looking at those properties. And so as we head into the future, we want to be able to use that to design new batteries and window materials and things like that. So as an example of what might happen in the data initiative, we might take these vast amounts of data that we're collecting, and people collect it for a reason, but then it's also placed into a repository and collected, hopefully, with an understanding that it's not just for that one experiment, but it's there forever. And we can have what we're calling crawlers. These will be little units of software that can crawl around, just like Google has crawlers that go around all the web pages trying to see what's inside them and index them. We'll have crawlers that go around and look at all the scientific data and will help people to recognize that there are relationships in the data that they had not even hypothesized in advance. So it's quite possible that we'll have a new method for making scientific hypotheses based on these large amounts of data. So that's an initiative that the lab is undertaking. The third scientific initiative relates to the light source. And let me just take one moment and remind you what the light source does. When Lawrence invented the cyclotron, what it was doing was taking a charged particle like an electron and making it accelerate in a circle, right, going very, very fast. And that goal was to smash one particle into another. And what they found in that era was that as they kept trying to accelerate the particles to go faster and faster, they'd put more energy in, and the particles didn't go any faster. And so the question is, how could that be? How could you put more energy into making the electron spin around faster, and yet it wasn't going any faster? You were putting energy in, where was it going? And eventually, what they found was that when an electron moves at a substantial fraction of the speed of light, and it makes a curved motion, it sends out light in the tangent to that circular motion. And that's where the energy was going, light. And it turns out to be phenomenally bright light when the electron is made to accelerate in that way, and when it's a tiny, tiny beam. So that's what the advanced light source is built off of. Now, when you try to do that, it's like if you try to take a turn with if your car's going very fast and you try to take a turn, you'll kind of skid out of your curve, right? That kind of happens with the electrons too. It's pretty easy to confine them in the vertical dimension, but in the horizontal dimension, where they're making this incredibly fast curved motion, they tend to spread out, okay? And so what the scientists have been trying to do for a long time is to make them not spread out so much, because if they spread out less, then the light that eventually you see becomes much more focused and much brighter. And so recently, the scientists have found a concept for how it might be possible to take a beam that kind of looks like this in the horizontal dimension and really compress it down to be much, much smaller. And if you think of this as the little point source that illuminates a microscope, this will mean that we can look inside a battery or a solar cell or even a protein and see things much better. It'll make much finer resolution maps of energy devices and living things. And one thing about it is that we can take the existing light source and perform this transformation to it for, on the scale of these types of things, a much smaller budget than building anything completely new. And it still will produce completely new science. So that's where we're headed with this project. And just to give you a feeling for it, there are these magnets that are used to control how the beam moves, and these are the old magnets, and this is the old, these are the current magnets that are there now with a tube, and then these would be the new magnets and the new tube fitting completely inside the one that was there already. In other words, everything will get compacted down. It will be much smaller. It will actually be quite a tiny little tube that goes around in this large circle. So, as I mentioned to you, that will be used to make a new kind of microscope. So these are the three science initiatives of biology, computing and data, and one that's based on this new type of microscope. And one thing that I want to point out is that these three initiatives all relate to each other very strongly. As an example, this microbial experiment is actually by itself generating huge amounts of data that will feed into this initiative, and this initiative will in turn help the biologists to do their job much better. And you think you can readily appreciate the same thing is true with the light source. It's already producing vast amounts of data, but when it's upgraded, it will produce much more. So this initiative becomes much more important to it. And these talk to each other as well, because this microscope will enable people to look inside and understand much better what's going on. So they're all kind of connected with each other. And now coming to your question about futures of the physical space at the laboratory, here's the light source, and here's where the computing activities will all be residing. Now, you can see some of the things going on at the lab. This is that Solar Energy Research Center, and this is the general purpose lab that you saw in the previous presentation. If you went and looked at the lab a few years ago, what you would have seen is this whole zone right here was a pile of really kind of cruddy shacks. So these two buildings represent the first phase of the, making Old Town into a more modern laboratory. And this just shows an artist's rendition of what will happen, because we do have the support now to demolish the rest of these buildings, and that's in progress. And you can also see here the demolition of the Bevatron, which had resided here previously, and which we had hoped perhaps would be the site of a future light source of some type, but now we know that's not going to be the case. So this site is a site at which there could be future construction at the laboratory, and this site is one where there could be. And you can see the light source in the computing, and if you just look at this a little bit and you go back and you look at this, you can kind of begin to realize that we should be considering also the possibility, if we're only able to build biology things very slowly, because we won't be able to do a rapid consolidation of our biosciences in the biology environment we live in, that these become potential locations for some of the biology activities of the microbes to biomes kind of activity that we're talking about. We certainly have to consider that as a possibility. A lot of construction is going on, and I just wanted to point out to you, because as I mentioned to you, we've had this safety initiative. We've done unprecedented amounts of construction, and during that period, the incidence of recordables, or what are called recordables, or days away from work, has been dropping steadily. Still have more to do, but that's been getting better and better. Now, these three science initiatives are all nice science, but ultimately people would like to see those things tie to the real societal needs in energy and environment innovation. So I'd like to talk with you about that aspect. The lab has an incredible legacy in this area. I think if we would certainly like to call this the Rosenfeld effect, as it is typically in all the media and newspapers where you'll see it. This shows the electricity use per capita as a function of time in the United States as a whole. And here in California, we can see that it became completely flat, and that's because Art, who was a high-energy physicist at the laboratory, decided in the early 70s to shift his attention to this issue of energy efficiency, and he had an enormous impact both on the technology and the policy. So that's a big effect that the laboratory's had, and we've had a lot of spin-out companies. So we do a lot of things that we would call having an impact on energy innovation in society, but our sense is that these are the carbon cycle 2 related activities at the laboratory. Compared to a few years ago, we have much more significant programs in areas related to batteries, making new kinds of solar to fuel, biofuels, capture and storage, all of these areas. The lab has really got a lot more science activity going on than it ever had before. And so we're thinking about how we can make sure that all this new science that is going on will translate better into real world impacts. Here's an example of something that we're starting. Now, the lab has been doing a lot of battery research, and it's grown enormously in the last few years. We're now we're playing a really key role here. There turn out to be about 40 startup companies in the Bay Area that are trying to help the electric vehicle take off. Okay? They're mostly all startup companies, not all, but mostly little companies. And a lot of them face common problems. They may have some unique aspect of their technology, but there are also certain things that they need to overcome in common as an industry as opposed to as an individual company. So we've played a big role in bringing them together into what's called CalCharge, which is a consortium, and that consortium is going to ultimately try to identify what are the common technology problems they all face, and how could, for example, a lab like ours really help them deal with that. So this would be an example of an activity in which the lab's science in energy could translate more concretely into energy technology. And so here are some of the things we're doing in the energy innovation space, which has this aspiration of doing that kind of thing for all the aspects of the carbon cycle. We've recently created what we're calling an energy technologies area, so we've made a kind of a part of major administrative part of the laboratory associated for this, and we're recruiting an associate lab director to help us formulate a more comprehensive strategy in this area. We're also searching for a new head for what's called technology transfer, but involves essentially dealing with all aspects of intellectual property and also how to help foster connections in a practical sense with businesses large and small. Now, with respect to the Richmond Bay campus, as I mentioned to you, our original plans were to try to consolidate our biosciences there, which would bring a lot of people there. But the budget reality is mitigating against that. But our commitment to the Richmond Bay campus as a future location for us remains very strong, and we're in very intensive discussion with UC Berkeley. And our goal will be to take things like that CalCharge program and have those be based on the Richmond site. And part of the reasoning behind that is that the Berkeley campus also does not have historically a site at which it engages directly with these types of issues and could use one very much. So I think it's a coincident need for both the Berkeley lab and the Berkeley campus, and this makes a logical activity. And also to be, putting out there some of the issues, there's also multiple ways in which we can get this started. We can get this topic started on the Richmond site sooner because there are more ways to get it financed and to get it started. So those are some of the things that we're looking at in that space. Clicking, but it's not going. Why is that? Did I turn you off?